Hello friends. So uh, today we're going to see what is meant by a partial differentiation. That is the introduction to partial differentiation. I am Abhijit Balakrishnan, Assistant Professor in Mathematics, Marathwada Institute of Technology, Aurangabad, Maharashtra. So we'll see what is the outline. The core of this presentation is to give brief study of partial differentiation of functions. So there are some key points what we are to see in this lecture. So today we're going to see what is the introduction, first one, then we'll see the different notations are there, some notations of partial differentiation, then we'll see some basic solved problems. Once we get a basic idea about the differentiation and what is the difference between total derivative and partial derivative, then we'll try to solve some higher order partial derivatives and some examples on that. So there are two ways of differentiation of function. First, there is ordinary differentiation, and second one is partial differentiation. What is the ordinary differential equation and what is partial differentiation? So this is a slight change, but this change differs more. And ordinary differentiation, it is an instantaneous rate of change, and a partial differentiation is an instantaneous rate of change for a function of multiple variables. So this is a major difference. When a function having more than one variables, that is multiple variables, we have to use partial differentiation. And normally if function having a single variable, we can use the normal derivative, that is called ordinary differentiation. Okay, so this is a change. When a function having more than one variable, and if we want to differentiate it, we have to use partial differentiation. This is all about the difference between these two, ordinary and partial derivatives. Most of the times earlier we have used ordinary differentiation, but this is new concept to you. What is the difference between ordinary and partial differentiation? So the main difference is when a function having more than one variable, and if we want to find the derivative, its derivative, so one function to be treated as a constant, so other derivative will differentiate other with respect to other variable. So that's why we call it as a partial differentiation. So we'll see, let us suppose one function z equal to f of x comma y, and if we want to find its derivative with respect to x regarding y as a constant. Okay, what we have to do? We differentiate z, the function z, with respect to x, keeping terms of y constant. The resulting derivative is called the partial derivative of z with respect to x, and it can be written as dou z by dou x, or dou f by dou x, or dxf, or simply fx. So all these notations, they denote the partial derivative with respect to x. Okay. Similarly, the partial derivative of z with respect to y regarding x as a constant, it is called a partial derivative of z with respect to y keeping terms x constant, dou z by dou y, or it can be represented dou f by dou y, or dyf, or simply fy. So these are the different notations used to denote the partial derivative with respect to y. Once we know the basic idea about the partial derivative of function with respect to x and with respect to y, we can easily solve some problems. So these are some problems. First example, we have to solve if z equal to x square y minus 3xy, then we have to find two values, dou z by dou x and dou z by dou y. So here we have to find two values, dou z by dou x. What it means dou z by dou x? We have to find the derivative of z, partial derivative of z with respect to x, and we have to keep terms of y constant. Whatever the terms of y are there, we have to keep as a constant. And what is dou z by dou y? We have to differentiate z partially with respect to y, keeping terms of x constant. So in first one, y is a constant. In second term, x is a constant. Now we'll find out these two one by one. What is the given thing? Your given thing is z, x square y minus 3xy. I will find out the first value. What is the value of dou z by dou x? Dou z by dou x is nothing but partial derivative of z with respect to x, keeping terms of y constant. That is dou by dou x of, just we are substituted the value of z, x square y minus 3xy. Then, so simply we can separate them. So separate derivative of these two terms with respect to x. What is derivative of x square y now with respect to x? Now derivative of x square y with respect to x. See here terms of y are constant. Y is a constant, so I can write y outside. Just simply we have to find out the value of x square, derivative of x square. What is the derivative of x square? 2x. 2x into y. Y is constant. We are treated as a constant. So it is outside. Keep as it is. So this becomes 2x into y, that is 2xy. Minus. Now what is derivative of 3xy? Y is constant term. I will take y outside. What is derivative of 3x? That is 3 only. So 3y. So dou z by dou x is what? 2xy minus 3y. On the same way, we can find out the partial derivative of z with respect to y. Okay, so what will be changed? Just for differentiate with respect to y now. Earlier we have differentiated with respect to x. Here we have differentiate with respect to y. So while differentiating with respect to y, terms of x treated as a constant. Now terms of x are constant. So what is dou z by dou y? This is dou by dou y of x square y minus 3xy. So separate it. Dou by dou y of x square y minus dou by dou y of 3xy. What is derivative of x square y with respect to y? Now x square is constant, right on the outside. X square into dou y by dou y. Dou y by dou y is 1, only x square. Minus derivative of 3xy with respect to y, 3x. Because 3x is constant, I can write outside derivative of y with respect to y is 1. So x square minus 3x. So this is my dou z by dou y. Okay, so this is a partial derivative of z with respect to y, keeping terms of x constant. So this is dou z by dou y. Now easily we can solve the similar problem. Second problem, if z equal to x sin y minus y cos x. Again we have to find these two values, dou z by dou x and dou z by dou y. So dou z by dou x is nothing but partial derivative of z with respect to x, keeping terms of y constant. What is dou z by dou x? I just substitute the value of z. This is x sin y minus y cos x. Now differentiate x sin y with respect to x. The derivative of x is 1. Sin y will be as it is, only sin y. Minus y is a constant term, keep outside. Now derivative of cos x is minus sin x. So I have written the bracket so that there will be no confusion, because derivative of cos x is minus sin x. So minus into minus, that becomes plus. So the dou z by dou x is sin y plus y into sin x. And what is dou z by dou y? So only change is that we have to differentiate the same function with respect to y now. Now terms of x are constant. So derivative of x sin y minus y cos x with respect to y, keeping terms of x constant, is x cos y minus cos x. So this is a dou z by dou x. Here I have supposed the function z having two variables x and y. We can suppose function z having three variables x, y and t. Okay. So what will be changed? Then we can find the three values, dou z by dou x, dou z by dou y and dou z by dou t. So what is dou z by dou x? So while finding value of dou z by dou x, we have to find the partial derivative of z with respect to x. Here in this case, terms of y and t are constant. Okay, so remaining two variables treated as a constant. Similarly, in the case of dou z by dou y, we have to keep x and t constant, and remaining terms, remaining thing we differentiate with respect to y. Similarly, dou z by dou t, it is nothing but derivative of z with respect to t partially. Okay, so this is a case when I have used the three variables x, y, and t. Once we know how to find out the single derivatives of single partial derivatives, we may come across a problem where a function having two variables but higher derivatives were to find out. That is, we have to find double derivative, we have to find a triple derivative and higher order derivatives. So we'll see how to find out the higher order derivatives. In this case, here I have supposed one function z, it is a function of two variables x and y. Then some notations are denoted. What is dou z by dou x square, what is dou z by dou y dou x, what is dou 2z by dou x dou y, and what is dou 2z by dou y square. So one by one we'll see. What is dou z by dou x? So dou z by dou x square is nothing but double derivative of z, partial derivative of z with respect to x two times. Okay, so what differentiate the same thing two times. See, you can see this. So first you find the value of dou z by dou x, whatever the value we will getting, then differentiate this value with respect to x again, we will get this value dou 2z by dou x square. Similarly, I can find the value of dou 2z by dou y dou x. So this will be dou by dou y of dou z by dou x. So first you find out the value of dou z by dou x. Easily you can find the value of dou z by dou x. Dou z by dou x stands for partial derivative of z with respect to x, keeping terms of y constant. Once we get this value, then the value is differentiated with respect to y, keeping terms of x constant. We will get the value of dou 2z by dou y dou x. On the same line, I can find out dou 2z by dou x dou y, and lastly dou 2z by dou y square. Okay, so dou 2z by dou y square, it is nothing but the double derivative, partial derivative of z with respect to y. Find out dou z by dou y, again differentiate with respect to y, we will get dou 2z by dou y square. Okay, so these are the different notations to find out the higher order derivatives. And always keep in mind there is one property of partial differentiation. Dou 2z by dou y dou x and dou 2z by dou x dou y, they are always same. Okay, why they are same? Just we have interchanged the sequence. Here I have differentiated with respect to x first and then with respect to y. Here I have differentiated with respect to y first and then with respect to x. So there will be no change, it will be same. Answer will be same. Now question may be asked like this on this. Prove that dou 2z by dou y dou x and dou 2z by dou x dou y for some value of z. So we'll get the same answer. Now here, for practice purpose, we'll solve one problem. Let us suppose z equal to x cube y square plus sin y, and we have to find two values, dou 2z by dou x square and dou 2z by dou x square, dou x dou y. So next values you can find, you can try yourself. You can find the value of dou 2z by dou y dou x and dou 2z by dou y square. So you can solve this. So for practice purpose, just we solve first to what is dou 2z by dou x square. Given what is my z, x cube y square plus sin y. What is dou 2z by dou x square? This is equal to what? Double derivative of z with respect to x partially. Okay, so dou 2z by dou x square is equal to what? Derivative of partial derivative of z, x cube y square plus sin y. So separate it. What is derivative of x cube y square with respect to x? This will be just what difference with respect to x. So derivative of x cube is 3x square, y square will be as it is, plus derivative of sin y is 0. And next thing, we have to find the derivative of this thing with respect to x. Now derivative of x square again is 2x into 3x, that is 6x, y square will be as it is 6xy square. So this is value of dou 2z by dou x square. On the same line, we can find out the value of dou 2z by dou x dou y. This is nothing but dou by dou x of dou z by